Sure. So I take it we are at 7.3, ne? Okay. As already, these are understandable questions. So now we are looking at 7.3, and they say the graph y is equals to f prime x has a minimum turning point at the coordinate 1 and negative 3. And they say determine the values of x for which f is concave down. So, okay, they gave us y is equals to f prime x. And then they gave us that this graph of y is equals to f prime x. So basically, this is my first derivative, right? It has a minimum turning point. So already from the first derivative having a minimum turning point at 1 and negative 3, we must determine the values of x for which f. Now f is my original graph. F is my original graph. Who's this? Okay, so F is my original graph. So let's do this. So usually, in most cases, when they give you a derivative and they tell you that the derivative has a minimum turning point, that means the original graph, in most cases, usually for questions like this, the original graph is a cubic graph. Right? With a cubic graph. So a cubic graph, as I've shared before, it will look either something like this, as if A is positive, right? Or it's going to be something like this now, if A is negative. So this is basically, this is my F. These graphs are my F, basically. But it can only be one. But since we don't have all the information, it can be either one of these two, right? And then now let me just write it properly. This is my f of x. And then my f prime x now, well, what will it be? So if I have a cubic graph, ne, and I'm deriving it, my derivative is going to be a parabola, right? So it can either be like this, or actually no. Let me swap them. So it will either be facing this way, smiley face, or frowning face. So now these are my f prime x. So with this question, it needs you to know your theory a lot when it comes to calculus, right? So okay, let's read again. They're saying the graph y is equals to f prime x has a minimum turning point at 1 and negative 3. So if it's a minimum turning point, this is my derivative. So the minimum turning point will be here. Ne? So it's 1 and negative 3. That's my minimum turning point. So now they are saying that, okay, determine the values of x for which f is concave down. So, okay, let me do this. Let me mute this person. Sharp. As I was saying, so there's a relationship between these two, né? Between the graph and the turning point. So in my original graph, the turning points here are going to be now my what are going to be my x-intercepts, right? But the x values of my turning points are going to be my intercepts. And then now the turning point here, let me change color. Please listen carefully. The turning point on my first derivative is going to represent now the point of inflection. The point of inflection of my original graph, right? So if they're saying now determine the values of x for which f, which is this original graph, which is this guy, will be concave down. So if here now my x coordinate is if here now my turning point is 1 and -3, that means my point of inflection here will be 1 and -3, right? Because I said that my turning point in my derivative is my point of inflection in the original. So sharp. So now it's just a matter of figuring out that where will this graph become a concave down. So this is my turning point. So for concave down, you'll basically go from here and going downwards. So the graph is going down. So this is my concave down on my left hand side basically. And then from here, my graph is going below. Then after, it's going all the way up. So this is concave up. So basically, if my x value here is negative is 1, for my concave down, my values of x must be less than 1. So that's the answer. X must be less than 1. Because if x is less than 1, we are either here, until negative infinity, right? And then we know that from my point of inflection going to the left, this is my concave down. Is that okay? Is that okay? Any question? So these are the questions that you guys need to focus on a lot more. Because already with these ones, you are okay with them, right? So these are the questions that you need to focus a lot more. And as I said, it needs you to have a strong knowledge in terms of your what's this your theory. So are we good or can we continue?
So,
Yeah.
yeah, ka e ke sharp ne mara o na le question e nngwe like ampore e tshwana le ke re ngwetseng ka yona di-prelim ya mo o ikufa yona ke like yona ke tlhaloganya re ka etsa bjang like e similar mara yona it's for more marks.
Okay, yeah, you can send it. We will try and squeeze it in our lesson. So from here, yeah, these are just the first questions, né? So the first three questions, these are the first, or these are just like the first ones. So already we have this, we did this, we did this, then we did this one. So I want us to look at now 3D calculus. I want us to jump to 3D calculus quickly. where's that one? Yeah, here we are. Can you all see? So with question 9, they tell us that, okay, this is 3D calculus, by the way. So yeah, you guys need to familiarize yourself with this. Ne? It's going to be there whether you like it or not. So the sooner you can do it, the better. So they're saying the diagram below shows a solid triangular prism. Triangular prism, right? The triangle is right angled with a height of 8x meters. So here it is. Let me change this. A base of 15x meters, yes, and a hypotenuse of 17x meters as indicated on the diagram. So they say the length of the prism is y meters. Here's my length of the prism. And the total surface area of the prism is 5,760 uh, square meters. Yeah. So now 8.9.1, they say show that y is equals to 5,760 minus 120x squared over 40x. So first of all, you see this 5760. So it's also here. So this is my total surface area, the 5,760. So what are we going to do? We are going to basically calculate the total surface area in terms of the lengths that we were given, right? Then we are going to equate it to the 5,760. Let me do it. So here's 9.1, right? So already, what is total surface area for those who might have forgotten? So total surface area is basically when we take the surface area of each shape here in our diagram. So we take the total surface area of each shape, and then we take the surface area, the area I mean, of each shape, and then we add them, right? Because this prism is made up of two uh, right angle triangles as well as three rectangles. So to make it easy, let me have a visual representation. So let's say this is now the rectangle here ne, at the back. This rectangle here at the back. Are you guys seeing it? Ne? So my question is, what is the area of this rectangle? So remember, the area of a rectangle is just length times breadth, right? So my length is y, and then yeah, so it's going to be y and then 8x. Gonna have my 8x. That's the first one. Length is y, and then my breadth is 8x, right? Then let's look at the second part, the second rectangle. So it's the basically the front of my shape. So this is a rectangle again, but then they have different what's this, lengths, right? They have different areas. So now my length is still y, but then my breadth is 17x. So my length is still y here, but then my breadth is 17x. That's the second one. Are we all seeing it? Are we all okay, by the way?
Yeah.
So you see, I'm just breaking everything down. Ne? I'm breaking everything down into smaller shapes. Oh no. Let me do this. Breaking everything down into smaller shapes. And then at the last rectangle, now, so we dealt with the back view and then the front. So the last one will be here at the bottom. And it will just be this. So already the length here is also y. Né? But then my breadth is 15x. So my length is y, and then breadth is 15. Then that's all of my three rectangles because I have three of them. Né? And then when it comes to now my two right angle triangles, they are exactly the same. So for my two right angle triangles, I can just do this. So I know that my base is 15x, my height is 8x, and my hypotenuse is 17x. So let me continue on this side and calculate their areas, right? So for the first one, we are here now. For this guy, the area is going to be what? Let me write it inside to not make things easy. So the first one, the area is going to be length times breadth. So it's going to be y times 8x. Then I can just write it as 8xy. Yeah? Then the second one, I just multiply them again. So it can be 17xy. Last one, 15xy. Right? But then for a triangle, we know that since it's a right angle triangle, our area is going to be half our base, which is what? 15x times the perpendicular height, which is 8x. So what is it going to be? It's going to be half of 15 times 15x times 8x. Né? So please just punch this in your calculator. What is this? How much?
60. Okay, 60x squared.
So yeah, it's 60x squared. Né?
Yeah.
So yeah, this is now my, what's this? My area for these triangles. But then this is for only one triangle. Né? And since I said we have two triangles, this is like the area for one triangle. So I'm just going to multiply it by 2. So it's going to be 120 x squared. Né? The area of both triangles. And also, you see a 120 here, then you also see a 120 here. So it kind of like it's a kind of a checkpoint or yeah, just to an indication that you're going in the right direction. So even here we already saw. Then okay. So here's what we are going to do. We are going to take all of these areas. Né? So since I said my surface area is just me taking all of my areas and adding them together. So here I am on the right, on the top right, I'm saying 8xy, which is this guy. And the area of the first rectangle, right? Then I add the area of the second one, which is 17xy. Then I add the last one, which is 15xy. And then now I add the area of the two right angle triangles, which is 120 x squared. And then when I add them, these give me like total surface area. What is this? It's going to be what? 5,760 as was given. So 5,760, that's my total surface area. So if I say 8 plus 17 plus 15, because they have like terms, I can add them together, right? So that's going to be what? I think it's going to be 40. Yeah, 40. So 40xy plus 120x squared is equals to 5,760. So from here, I'm just going to make y the subject of my formula. Yeah? So I'm just going to do a nice calculation and say 40xy. So I'm just going to isolate the 40xy because it's the only term that has a y in it. Then I'm going to have is equals to 5,760 minus, what's this? 120x squared. Then I'm going to divide both sides by 40x. And even here, I'm going to divide by 40x. Then now y is going to be 5,760 minus 120x squared over 40x. And yeah, it looks similar. Yes. So you see, they even made it a 2 marks. Né? But yeah, I don't think it should be 2 marks. It should be more than that because there's kind of a lot of calculations. But okay, so this is 40x. Are we all good, ne? Are we all good?
Yeah.
Sharp. So that was the first one. We got it. We just had to show. We just had to show. Then a 9.2, they say now hence. So already you know when you see the word hence, that means we are going to use this, ne, in our question. So they say hence show that the volume of the prism can be expressed as V of x is equals to 8,640 minus 180x cubed. So still, as I also said, sorry for that. Let me see. Let me try and fix this quickly. Let me see. Okay. Yeah, so here we are, 9.2. So they say, hence show that the volume of the prism can be expressed as 8,640x minus 180 x squared. So here, if you don't know the formula of the volume, then it's a problem. So we can just say now v of x, since they gave us v of x, we know the formula is going to be half a base times height and then times my beta height. Yeah? So that's the area of volume. That's the volume I mean. Area of volume. That's the volume of my triangular prism. So sharp. That's going to be a half now. And then the base. So what is my base here? My base is y, basically, right?
Mm.
My base is y. And then what is my height?
8x.
8x. And then what is my full height?
Okay, on full height 8x, I think.
No, it's not going to be 8x again. It's not going to be 8x again.
Tsebo,
Um, yes, I can hear you.
o tlositse screen sharing or ke monna fela? I think o kare ke monna o se fetse o
Yeah, I don't
like
know. There's something wrong with this network. There's something wrong with this network. So yeah, as I said, let me just do this now. Let me just quickly. So we are at 9.2. So this is nothing too difficult because it's only 2 marks. So our v of x is going to be half times breadth times height, and then times the bigger height. So okay, please listen carefully. So half already there. So my breadth now, we are going to look at the uh the triangle. Nah, not the breadth, the base. So the base of my triangle is going to be 15x, right? And then we are also going to look at the height of my triangle, which is a 8x. Then when we multiply it by the bigger height, that bigger height is going to be y. So yeah, let me give you guys a trick. If you find a question and it gives you what's this? It gives you a present, whatever present that they give you. So in this case, they gave us a triangular prism. If they want the volume, the volume of that prism, the volume of that prism will be made firstly by the area of the base. So the area, now our bases are what? Are the right angle triangles, right? So here's the area of my base, which is half base times height. And then we multiply it with the bigger length, basically. Always, whatever
mm.
that prism is, even if it's not a triangular prism, that's how you're going to go about it. So sharp, once we're here, now, but then we are going to change y, because we know that y is this now. So that's why they said hence, because we are not going to use y. 15x. What was the area of this guy? It was 60, right? So it was 60x squared.
Yeah.
And then we're going to multiply it with what? 5,760 minus 120x squared over 40x. Okay, how are we gonna do it? Now we are multiplying, so we are just going to say numerator times numerator. So just say 60 times 5,000. Okay, it's going to be big. So let's say 60 times 5,760. What is that?
Ke 345,600.
345,600. But then it's x squared. Ne? Then we have minus. So now say 60 times 120.
Okay, minus 7,200 x to the power 4.
7,200 x to the power 4. Then we are going to divide it by 40x. Ne? Divided by 40x. So it's going to be what? So we can either do one of the following. We'll just divide both sides by 40x. Ne? So we can say 345,600 x squared over 40x minus 7,200 x to the power 4 over 40x. Then what is it already? I know that this will cancel this. Then 345,600 divided by 40 should give us 8,640.
Yeah.
Then it's going to be x, then minus, then 7,200 divided by 40 should give us 180. And then we keep the base 4 minus 1, that's going to be 3. So we also see that.
Mm.
Then last but not least, yeah, this is the last one. Then sharp. They say now determine the value of x for which the volume. So already when they're talking about the volume, we are looking at this equation for which the volume of the prism will be a maximum. So don't forget, we are dealing with calculus, right? So whenever they tell you about maximum or minimum, what do we do? We derive. Ne? We derive.
Mm.
So to just get my maximum, my first derivative is going to be equal to 0 to be exact. So my v prime x should be 0 to get the maximum in this case, at the maximum. So I'm just going to have now 8,640 minus. So what's 180 times 3?
Ke 540.
540 x squared. Right? So I'm just going to have 8,640 minus 540 x squared is equals to 0. Then it's just a matter of me solving for x. Né? So it will just be minus 540 x squared is equals to minus 8640. Then I divide both sides by minus 540. So just then x squared is going to be what's this? I think it's going to be 16. Eh?
Positive 16.
Ke 16.
Yeah, 16. Then already you know that you must square both sides. Then yeah, x is going to be plus or minus 4, right? But then since they said it's a maximum, and volume talks about length, so your length can never be a negative. So therefore your x is going to be positive 4. Is that good?
Yeah.
Yeah. So okay guys, here's the thing. Let me stop the recording.